Hey boys and girls, welcome back to another edition of Crush Lusher Television. Alright, so what we're going to do is we're going to do these scrimmage multiple choice problems. Yeah, I know the multiple choice probably is not going to be on the AP. It's probably going to be just 2 free response, but it's good to hone our skills this way to make sure we know all the basics and all questions like this just in case they come up in one of the pieces of the free response, okay? So I want you to do 1, 2, 3, 4, 5, 6. Do all of these right now. And then press play on this video and see if you got the same thing as I did. Alright, so pause. Alright, cool. So this is U substitution problem. How do I know? Well, it tells me. It even gives me U. Ooh, good. What a gift. Thank you very much. So let's use that by knocking out this problem. Boom, here we go. Alright, so U is this. So U is radical x. Cool. So that would mean that du is going to be the derivative of this, which is 1 over 2 radical x dx. Nice. Okay, so now it's time to substitute. So usually when you have something like this, the exponent is where u is going to be. And so this is going to be, so let's start substituting. So this is going to be e to the u, but this over here, I have it very similar because I got radical x dx, radical x on the denominator, but I got this 1/2 here. Now the 1/2 is not here, so I can't substitute, so I got to get rid of this 1/2 so I can substitute for du. So what's the opposite of multiplying by half? Yeah, multiplying by 2 on both sides, because 1/2 times 2 is 1, and 1 times anything is itself. So 2 du equals 1 over radical x dx, which is this. This is 1 over radical x dx. All this fun stuff right there. 1 over radical x dx is the same as 2 du. So I'm going to substitute that. So I have the upper and lower limit. I'm not going to touch right now, but I have 2 e to the radical x. We said that was u. du. Now, we don't know the upper and lower limits because now we are in u world. We are in terms of u now. And so this 1 and 4 is in terms of x. We have to do it in terms of u. So I need to plug these in here. So u equals radical 4. And radical 4 is 2. So it looks the same. This is u. This is 4. So this is 2, the upper limit. And then u equals radical 1. Plug in 1 here. And so that's 1. And so the upper and lower limits is 1 over 2, so that is the final answer for number 1. Let's see what letter that is. I don't know. That looks like C, 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 C. Cool. Yeah, don't put B. That's a common mistake. Not fixing the upper and lower limits. All right, number 2. So we got a piecewise function. We got to find the integral. Means area under the curve. Okay, no problemo. All right. So here we go. So this comes with a picture. This is a piecewise function. I'm going to draw a little picture here. So 3, the graph breaks. So this is y equals 2 at this part. So 2 is right here. So open circle because it's just less than 3. So this is y equals 2 or f of x equals 2. And then x minus 1 when x is greater than 3. So if I plug in 3 here, so 3 minus 1 is 2. So when x is 3, y is 2, which is this. And then this slope is 1. So it's up 1 over 1, up 1 over 1. So it just goes like this. So this is like y equals x minus 1, and then y equals 2 right there. So you want to find the area under the curve between 1 and 5 of f of x dx. So this is 1, and this is 5 here. So you're going to find this area in this area. So you could do integrals if you want, or you can just do geometry. So this is a rectangle here. So this is going to be 2, and the height is also going to be 2 because this is y equals 2. So 2 times 2, that's actually a square, which is 4. So that area is 4. And this is a trapezoid, and so this height of the trapezoid is 2. This side is 2. Sorry, you can't see it. This side is 2. This side, 5, is the x. What's the y value? 5 minus 1, which is 4. So this height is 4 because that's the y value. So that's going to be 1/2 times the height, which is 2, times the two parallel sides, those are the bases, 2 plus 4. So half of 2 is 1. 1 times 6 is 6. So this trapezoid is 6, that's the area, and this is 4, so 4 plus 6 is going to be 10 is the answer there. So number 2, answer is 10. So that would be D. Cool. All right, so this one. So the graph of differential function f is shown as h of x equals the integral between 0 and x of f of t dt. So this is the graph of f. All right, so you got this little curvy curve, and it just concerns about what's going on at 6. So h of 6, h prime of 6, h double prime of 6. So what order do they go in from least to greatest, essentially? That's what I'm finding. Okie dokie. So here's my picture. Bam. So it always comes with this chart. We always write this chart. And so h of x equals the area under the curve, like that. So h prime of x, so that's the derivative of this, and the derivative of an integral is just the integrand right there when you plug that in. So that's f of x, because the derivative of this side is h prime of x, the derivative of the integral, those undo each other and you just have f of x. And then h double prime of x is the derivative of this is just f prime of x. So once you are loaded with this, you're good. So the first thing you want to find is h of 6. So h of 6 is the area under the curve between 0 and 6. So that's this area here, which is obviously negative. Okay, so h prime of 6, which means the slope at 6. No, sorry, just the graph. My bad, the graph at 6. So the graph at 6 is 0. That's the point. Okay, so now h double prime of 6, so that's f prime of 6. That's the slope of this. So the slope of this at this point, the tangent line like that, is positive. So if you're going least to greatest, negative, 0, and positive is how you go. So h of 6 is less than h prime of 6, which is less than h double prime of 6. There you go. So what answer is that? I do not know. Let's find out. H of 6 is less than h prime, so it's A. All right, 4. Same kind of thing. So you got to figure out what f of 1, f prime of 1, and f double prime of 1. Okay, so you just have this little curvy curve right there. This one's a little bit different, but we can get it. So it looks like this. So f of 1 is just the point. So the point there is 0. F prime of 1 is the slope, the rate of change. So the slope here, there's a tangent line right there, is a positive. I don't know what it is, but I know it's positive slope. F double prime talks about the concavity, and this is in a concave down situation. So that's negative concavity. And so if you're going from least to greatest, you go from the negative to the 0. Sorry, 1 here. And this is to the positive. Bam. Cool. So f double prime of 1 is less than f of 1, which is less than f prime of 1, which answer is f double prime of 1. So that'd be D as in dog. Okay, number 5. This one's a little bit lengthy, so we got to figure out where this is concave down, this function. So concave down, that's the second derivative. That's what you're talking about. So I gotta go to y double prime. So we have to do some mathematics here. So we gotta show a lot of work. So let's get our notebook out. Cool. All right. So here it is. So concave down. So first, in order to get to the second derivative, we need to get to the first derivative first, right? So power rule. 4 times 3 is 12 x to the third minus 3 times negative 16. Negative 48 x squared plus 2 times 24, which is 48x, plus 0, because the derivative of a constant is 0. Okie dokie. So y double prime. So now I go to the second derivative, because the second derivative is where I find my concavity. So that's going to be 3 times 12, which is 36x squared, minus 2 times negative 48, which is 96x plus 48. is the derivative of that. So we in. So this is the second derivative. So when is this concave down? When is this negative? That's what we're going to find out. So I need to do a little sign chart. So I got y double prime and then y. So I need to know where the inflection points are potentially. So I need to set this equal to 0 and figure out where the graph goes from concave up to concave down. So where is there no concavity? So then I can figure out what happens to the left and right of that. So I notice these, so I'm solving this, I notice these are all divisible by 12, right? So I'm going to factor out a 12. 3x squared minus, that's 8x plus 4. Bam. Okay, so factor out 12. So this is equal to 0 right now. All right, so 12 actually is not going to matter, so it just matters this. So I got a factor. Ooh, old school factoring. Love it. -8 on the top, and since a right here is greater than 1, I need to multiply 3 times 4, which is 12. So what adds to -8 and multiplies to 12? That would be -6 and -2. So I bring this down. 3x squared minus 6x minus 2x. These essentially become this, because -6x and -2x is -8x. And then just bring the last term down plus 4. No. And you can practice these if you need to, because this might be on the test. I don't know. They test everything that you've ever learned in math. So this is one of the things you should have learned. We have, what can I factor out of here? 3x. X minus 2, because that's yeah. Factor out a -2 here. X minus 2. -2x plus 4. Yeah, I always do the distributive property just to double check. And so the outside, 3x minus 2, x minus 2. All right, looking good. This equals 0, so x equals 2. And then 3x minus 2 equals 0 plus 2. 3x equals 2. So 2/3 is another one. Boom. Okay, so we have 2/3 and 2. Okay, so now I got to plug in here to figure out what's going on. So I'm going to plug in 0. So I have y double prime of 0. So what's going on here? What's my concavity? That's what I got to figure out. So it's 12 times 3 times 0. Actually, no, I'm going to do the sign chart. So it's 3 times 0 minus 2. Use this. And 0 minus 2. The 12 out here is positive. It doesn't matter. So this is negative and this is negative. Negative times negative is positive. So the real graph is going concave up. Y double prime of what's between 2/3 and 2? That would be 1. That's a good one to use. 3 times 1 minus 2, and then 1 minus 2. So this is going to be 3 minus 2, which is positive. 1 minus 2, which is negative. Positive times negative is a negative concave down. All right, what's going on after here? So let's put a 10 or something. I don't know. 3 times 10 minus 2 is positive. 10 minus 2 is positive, positive. So you have a positive right there. So you have concave down between 2/3 and 2. Boom, right there. So that would be E. There's the answer. And the answer to the last one actually isn't on here. It's between -2 and 1, and between 1 and 3. So it's between -2 and 1 and between 1 and 3. That's where f is increasing. If this is a graph of f prime, this is increasing going up and up, but it's not increasing at 1. So the graph is not there. All right, good work, everybody. Nice job. Make sure you redo any questions you got wrong. See you next time.